right, folks, so in lesson 4.6, you learned how to evaluate some trig ratios for certain angles. Those angles came from our special triangles, and those angles were 30 degrees, 45 degrees, and 60 degrees. And we're going to take advantage of that skill. In fact, in this lesson, we're really going to be relying on 4.1, 4.4, and 4.6. If you're feeling a little bit uncomfortable with any of those lessons, go back, review it. Make sure you're feeling good with those skills because we're really going to use them in here. Now, let's take a look and let's consider some angles, some 4 different angles in one in each quadrant as we work here. Now, we know how to label our quadrants. We're feeling really comfortable with this at this point. Quadrant 1 up here, quadrant 2, quadrant 3, and quadrant 4. We label them counterclockwise. Now, all right, so if I have an angle right here, I'm working in green in quadrant 1. If I have an angle in here, then my theta would be something like this. We'll call it theta 1 here. Now, using this angle, and in fact, it happens to be this angle, but we're going to be paying attention to the related acute angle. In this particular case, the related acute angle is equal to theta 1, and that's because we're working in, we'll call it alpha 1. That's because we're working in quadrant 1. Now, if we're working like this, we're going to play around, and we'll head to the arrow, the end of our arrow here, the tip of the arrow, and we'll draw a straight line down. And what this does for us, I'll move mine over a little bit so we can still see our label for alpha. What this does for us is it creates a triangle. What kind of a triangle? It creates a right angle triangle. So if we're working with a problem like this, then remember our theta, or really our alpha that we're paying attention to, is one of the interior angles. And this interior angle is the interior angle how we measure counterclockwise around our circle. So we're not really paying attention to this angle in here. We're paying attention to the angle inside here. Fantastic. Okay, so if that's our theta, then we should be able to label our sides in here, so, right? So we have an adjacent side, we have an opposite side, and we have a hypotenuse. Now in this particular case, our adjacent side would be along here, along the x-axis. And in fact, our adjacent side, let me see here, yeah, we'll just label it with x right now. Our adjacent side is x, and it's always going to be x because our x-axis is always going to be adjacent to our related acute angles. So my adjacent side right here, if I were to take a consideration of the length, or really our displacement from the x-axis, then I would say, okay, well, I have gone from the origin, my x-axis, I'm looking to the right of my vertical axis. And so where I'm looking right here, my adjacent side, I think you would agree with me, is positive. I don't know what the value is, but I do know that my adjacent side right here has a positive value because we're working on the right side of our y-axis. That's where my x values are positive. Now my opposite side here, okay, my opposite side to this angle could be given by my y distance right here. That's y. And really, if I'm comparing that, I could take a look, I could move that over, I could look across right here, and it's given by this y value. So my y value is my opposite side right here. My opposite side I'm looking, and my opposite side, well, I'm looking up above the x-axis. That means my y values are positive here as well. Now a quick rule of thumb we're going to use in here, our hypotenuse is our hypotenuses are always going to be positive. So if we're working in the first quadrant, then our adjacent side, our opposite side, and our hypotenuse are all positive. Nice work, folks. This might seem a little bit rudimentary, and that's okay. I'm hoping you're following. We'll jump in now, and we'll look at an angle in quadrant 2. Oops, bear with me here. Good, there we are. So an angle in quadrant 2 will look something like this. Now, if we're working like this, then that means our angle theta would be something like this. We'll call this theta 2, and in fact, I'll label it in my second quadrant just so I keep everything neatly placed. Now, I could create a triangle. This triangle will have, again, I'll draw it down from here. This triangle's interior angle will always be its related acute angle, Fantastic. So I'm working here. I have a related acute angle. Now in this case, again, I'm referring to this related acute angle. My adjacent side will again be given by my x distance here. But my x distance this time, my x distance is negative because I'm working to the left of the y-axis. So here I'd write, okay, so my adjacent side is negative. Fantastic. Then we'll take a look. All right, so if my adjacent side is negative, we need to find our opposite side. So opposite to my related acute angle, I'm working way over here. This side, vertically speaking, is above the x-axis. So my opposite side is positive because that's where my positive y values are. My hypotenuse, like we said last time, always positive. Nice work. All right, then, let's push on forward. If we're working with an angle in our third quadrant, then it might look something like this. And if we're working with this angle in our third quadrant, then our angle theta could be sketched like this. It goes all the way around in a counterclockwise fashion from the positive x-axis. Let's give that a little more uniformity. There we go. And a related acute angle right down here. My related acute angle, we'll call it theta 3. My related acute angle would be the interior angle to a triangle I would draw. So as this interior angle, I could take a look at my adjacent side. Well, my adjacent side, again, it's always the x value. My adjacent side is the side right here. Okay, so I'm still working in the negative with negative x values, so my adjacent side is negative. My opposite side this time, okay, so my opposite side to this angle, I'm working down here. This opposite side, well, it's gone down from my x-axis, so that means my opposite side, is negative here. And then my hypotenuse is always going to be positive. Fantastic. And lastly, I'll encourage you folks, let me see here, I'll use a nice gray color. I'll encourage you folks to sketch, actually, well, I'll sketch one together, and I'll encourage you folks to interpret our adjacent side, our opposite side, and our hypotenuse. Are we going to be working with them positive or negative right down here? Adjacent side, opposite side, hypotenuse. I'll encourage you to pause the video, fill it out, and then come back. Lovely. So in this case, we should be working with a positive adjacent side, with a negative opposite side, and again, a positive hypotenuse. Now, if that's the case, if all of these are the case, then let's go back and we'll look at our work in our first quadrant. So here we're going to use these adjacent, opposite, and hypotenuse sides in order to determine which ratios are going to be positive. So here, if I'm working, okay, so if I'm working with the sine of theta 1, then I'm going to be working with here, okay, well, I know sine is opposite over hypotenuse, and I know my opposite side is positive. I know my hypotenuse is positive, so my sine of theta here will be positive. Fantastic. All right, if that's the case, then I can check with my cosine of theta 1 as well. The cosine of theta 1, I know I'm working with my adjacent side over my hypotenuse. That is a positive value divided by a positive value, and I'm working with a positive. Fantastic. And lastly, my tangent of theta 1, again, using the same logic, I should find that my tangent ratio should be positive. Fantastic. Again, that might seem really, obviously pretty consistent right here. All of our values are positive. They're made up of only positive values. Fantastic. We'll see where we're going as we get over here. And you know what? What I might write down here, I can sum all of this up and I can say, okay, which ones are positive? All of them are positive. If I'm working in quadrant 1, all my ratios are going to be positive. Now, and you know what? I apologize, folks. I should have thought it through a little bit more. I did not. So you've run out of space perhaps over here. If that's the case, then you can just write down your work over here. You're working with the sine of theta 2, and you can fill it out there. But I'm going to fill mine out along the side here so that when I upload it to the classroom, you'll feel comfortable with where we're working. So here we're evaluating, okay, so the sine of theta 2, well, the sine of theta 2 is going to be, again, the opposite divided by the hypotenuse. That's a positive divided by a positive, so we're working with a positive ratio. Now, the cosine of theta 2 is going to be my adjacent side divided by my hypotenuse. That's a negative divided by a positive, and that will end up with a negative ratio. All right, my tangent of theta 2 is going to be my opposite side, a positive, divided by my adjacent side, which is a negative. So I'm working here, okay, positive divided by a negative will always, always, always result in a negative value. So that means the only ratio that's positive in quadrant 2 is my sine ratio. Fantastic. Using this same logic, folks, I encourage you to try it out with theta 3, the sine of theta 3, the cosine of theta 3, and the tangent of theta 3. I'll encourage you to pause the video, try it out, and then unpause. Good, so we should be working here with a negative sine ratio with a, negative cosine ratio and a positive tangent ratio. So we would say here, okay, so my tangent ratio is the only positive ratio here, tangent. Fantastic. And lastly, I'll encourage you folks, try it out for quadrant 4. Pause the video, come back to check your work. Good, so we should be working here with a negative sine ratio, with a positive cosine ratio, and a negative tangent ratio. So when we're working in quadrant 4, then cosine is the only ratio that's positive. Now these observations, if you were able to follow all of that work, fantastic. These observations that all of them are positive in quadrant 1, sine is the only ratio positive in quadrant 2, tangent is the only ratio that's positive in quadrant 3, and cosine is the only ratio that's positive in quadrant 4. These observations can be summed up by what we call the CAST rule. We take the CAST. So we start our CAST rule in quadrant 4, and then we work in a counterclockwise direction like so. Now these tell us if our ratios are going to be positive or negative depending on the value, depending on the angle that we're taking. If the angle falls in quadrant 1, then all of its ratios will be positive. If the angle falls in quadrant 2, only the sine ratio will be positive. All of the other ratios, each of the other ratios, will be negative, and so on. And so on. Now, we're going to come up with some steps so we can evaluate our trigonometric ratios where our related acute angles, that's our key, where our related acute angles are special angles. Where related acute angles a special angle. Those special angles, like we listed up above, 30 degrees, 45 degrees, and 60 degrees. So that's what we'll work with here. So we'll start off, and we always want to, bear with me, folks. Good, rather than you folks watching me write it out. So we'll start off by sketching our angle. So we'll work here with example 1, and we'll start off, and we want to sketch, okay, the sine of 210 degrees. Well, if I'm sketching that, call it step 1 right here. If I'm sketching the sine of 210 degrees, I know, obviously, I start from my positive x-axis. That's where my initial arm lies. And then my terminal arm is going to be 210 degrees counterclockwise from here. Well, I know 90 degrees is up here. I know 180 degrees is over there. And I know 270 degrees, 270 degrees is 3/4 of the way around. So 210 will fall somewhere in between 180 and 270. Fantastic. So I'm working in here something like this. We've sketched it. Good job, us. That's step 1. Step 2, we want to find our related acute angle. Well, if we're working in quadrant 3, we can come up with our related acute angle just by logically thinking about it, right? Our related acute angle in this case, well, hang on. If I compare my sketch, okay, well, I know it's a little bit more than 180 degrees, right? My sketch, 210 degrees, is a little bit more than 180 degrees. So that's 180 degrees here, and then I have my related acute angle. So I would say here that 210 degrees here is equal to 180 degrees plus my related acute angle. You can see how useful sketching this is here when we're finding a related acute angle. So now I can rearrange this. That means 210 degrees minus 180 degrees is my related acute angle. And that tells me my related acute angle is 30 degrees. Well done, folks. That's step 2. Step 3, we're going to work with our CAST rule. So our CAST rule, if we're stating our CAST rule, then what we're doing is we're saying, okay, cosine, all, sine, and tangent. Those are the ratios that are positive in each of these quadrants. And what that means is if we're working with a terminal arm in quadrant 3, that means my tan ratio ratio is positive. And what that means is that my sine and my cosine ratios are negative. Fantastic. Do you need to write this part down every time? No, you don't. Just writing out your cast rule is fine. But I'm hoping to write those down this time so that you can follow along. So if that's the case, okay, so we're going to take advantage of a little bit of symmetry here. All right, so if that's the case, we have the sine of 210 degrees. That's what we're working with here. Now, are we expecting this to be a positive ratio or a negative ratio? Well, I'm working in quadrant 3. In quadrant 3, my sine ratio is negative. So this is going to be a negative ratio. Now, if we take advantage a little bit of some symmetry. Okay, so let's try sketching a triangle in right here. If that's the case, then I know I have a 30-degree angle in there. Well, hang on. Don't I have a special triangle that has 30 degrees there? I do. So I could come up with the ratios from this triangle, which is in fact a special triangle. It's just written with an orientation you're not used to. I could come up with it by relating my, my ratio to that of a special triangle. So this is going to be equal to negative the sine of my related acute angle being the 30 degrees that I already found in step 2. So I'm working here, and I have the negative the sine of 30 degrees. Will I always make this negative? No, only if my cast rule says to. But I'm working here, okay, so my sine of this, I'm working with negative the sine of 30 degrees. Now I should be able to, and bear with me here, we'll grab a green color. I should be able to sketch the relevant special triangle. So you should be able to sketch a special triangle with a 30-degree angle. Try it out right now. I encourage you, pause the video, sketch your triangle, and then unpause to see how you did. Good, so our special triangle should look something like this. I'm working with 30 degrees. And what I'm trying to evaluate is the sine of 30 degrees. Okay, so the sine of 30 degrees is going to be equal to my opposite side divided by my hypotenuse. Okay, well, the opposite of 30 degrees is 1. My hypotenuse is 2, so I'm working with the sine of 30 degrees is 1 over 2. And if that's the case, then I should be able to, and this is our final step. In fact, I'll still work color-coded up here. This is going to be equal to negative, okay, so I can substitute that in. Well, the sine of 30 degrees, instead of writing that this time, I'll write 1 over 2. So that means that the sine of 210 degrees is equal to negative 1 over 2. So I encourage you folks, throw that into a calculator. Double check your work. If you throw that into a calculator, it should say negative 0.5. And what you just did here in class, using the skills that we've learned in this chapter, you just evaluated the sine of 210 degrees without using a calculator. Well done. Not only that, you justified your work. So if you're showing work like this on a summative, then you need to make sure you're showing all of the work that we're showing here. Number 1, you need to make sure you sketch your angle. Number 2, you need to make sure you show your work finding the related acute angle. Number 3, you need to make sure you show your cast rule in here. And in doing so, you need to interpret okay. You need to convert this sine of 210 degrees is going to be equal to negative the sine of 30 degrees. We're showing that work. And then you need to show your work, including the sketch of the special triangle on every single problem you're using it. You need to show the special triangle and evaluate the sine of 30 degrees so that we can evaluate the negative the sine of 30 degrees. Well done, folks. So our next problem, we'll just practice this a little bit more. They're not asking us to find a single trigonometric ratio for 135 degrees. They're actually asking us to find all of the ratios for 135 degrees. So we're working in here. All right, we start off with a sketch. We know how to sketch 135 degrees. I know 135 degrees is between 90 degrees and 180 degrees. I'm working counterclockwise from my positive x-axis. I'm working with something like this. So here is 135 degrees. Well done, that's our first step. Our second step is to evaluate, okay, my related acute angle. Now, if you're feeling really comfortable with these skills, folks, pause the video, try it out on your own, and then every step that you do, unpause the video, watch me do it, and see how you did. All right, so my related acute angle, well, I know that 180 degrees is half a circle, and I know that in order to get to half the circle, I need to go 135 degrees plus my related acute angle. So here I would say 180 degrees is equal to 135 degrees plus alpha. So that means that alpha is going to be equal to 180 degrees minus 135 degrees. Fantastic. That means my related acute angle is 45 degrees. Well done, folks. That was step 2. Step 3, I'm stating my cast rule. Okay. Cosine, all, sine, tangent. So that means my sine ratios are going to be positive in this quadrant, and my cosine ratios, my tangent ratios, are going to be negative in this quadrant. Fantastic, nice work. Now, in this problem, it's a little bit different because we're determining the 6 trig ratios for 135 degrees. Then we'll actually have to show a little bit more work right here, because really what we're evaluating are the cosine of 135 degrees. I'm evaluating the sine. I'm not sure why I wrote it in that order. I apologize. I'm evaluating the sine of 135 degrees, and I'm evaluating the tangent of 135 degrees. Not only that, but I'll also be evaluating the secant of 135 degrees. I'll also be evaluating the cosecant of 135 degrees and the cotangent of 135 degrees. All right, well, the cosine of 135 degrees. I know in this quadrant, cosine is negative. So that means I'll be working with negative the cosine of the related acute angle. My related acute angle in this case is 45 degrees. 45 degrees. And I missed a degree symbol down there. Fantastic. My sine is positive. So in this quadrant, I'm working with the sine of 135 degrees is going to be equal to positive the sine of 45 degrees. My tangent is going to be equal to negative the tangent of 45 degrees. And I'm color coding mine, so I'm writing them in a slightly different order, but there we are, filling in the blanks. Now the question comes, okay, we've learned how to do that, but we have not learned how to evaluate our reciprocal angles, our reciprocal ratios. Well, I know that the secant is just 1 over the cosine. Okay, well, if 1 over the secant of theta, if secant is equal to 1 over the cosine of theta, then if my cosine ratio is negative, then my secant ratio will also be negative. So I'll be working over here with negative the secant ratio of 135 degrees. Do I have to show all of this work? Not necessarily if I'm working with my reciprocal trig ratios, because I could evaluate them later. And you'll see that shortcut in a moment. I'll only show the work here. You'll see where we get, secant, negative the secant of 45 degrees. There we are. Now, okay, so we're done step 3 in here. That was step 3. Now we need step 4. We need to find and sketch the relevant special triangle. And I think we used a blue, nope, we used a green color there. We'll stay consistent. So we know our related acute angle is 45 degrees. That means we need a special triangle with a 45 degree angle. Luckily, we know just the one, side lengths 1 and 1, and then the square root of 2. And I know I'm working with 45 degrees with both of my interior angles. Fantastic, we're masters of that right now. Now, if that's the case, then I should be able to evaluate the sine of 45 degrees. And you know what? Sorry, folks, I'll keep my order consistent, at least. The cosine of 45 degrees, the sine of 45 degrees, and the tangent of 45 degrees. Right, my cosine of 45 degrees, well, let's choose this one. My cosine is my adjacent side over my hypotenuse. So that is 1 over the square root of 2. All right, my sine is my opposite side over my hypotenuse. So again, 1 over the square root of 2. And the tangent is the opposite side over the adjacent, so I'm working with 1 over 1, and that simplifies just to 1. Good. So if that's the case, now I can substitute in to my work up here. The cosine of 135 degrees is equal to negative the cosine of 45 degrees. So that means I'm working with negative 1 over root 2. And I'm just going to change my layout. There we are. Negative 1 over root 2. All right, my sine of 45 degrees is equal to my sine of 135 degrees is equal to the sine of 45 degrees, and that is equal to 1 over root 2. And you'll see now that, yes, they share the same magnitude, but one of them has a negative value, the other is not. The other is positive, and that came from our cast rule. the tangent of 135 degrees is equal to negative the tangent of 45 degrees, so that is negative 1. Fantastic. Now, if that's the case, okay, so I could work through here, and I could say, okay, negative the secant of 45 degrees, let's say, working here. Okay, well, the secant of 45 degrees, I can go down here. If the cosine of 45 degrees is 1 over 2, then the secant of 45 degrees would be equal to root 2 over 1, and that is root 2. Okay, so then I could say, well, if I'm working up here, then I'm working with negative root 2. Good. But I don't need to go through and show all of that work, because I know my secant ratio is going to be my reciprocal of my cosine ratio. So I can skip a step in here. I don't need to state necessarily this line every time if I'm working with reciprocal angles if I've already found my primary ratios. So here I found my primary ratio. My sine of 135 degrees is 1 over root 2. So my cosecant of 135 degrees is simply the square root of 2. If my tangent of 45 degrees is negative 1, then my cotangent, if my tangent of 135 degrees is negative 1, then my cotangent of 135 degrees is negative 1 over 1, or really it's 1 over negative 1, which is negative 1. We're there, we're following. I think it makes a lot of sense. Now, I'll ask you folks for practice. On the note I uploaded to the classroom, these will be filled in. For practice, evaluate the cosine of 120 degrees, the sine of negative 120 degrees, and the tangent of 480 degrees. We're going to work here with one more example. We'll squeeze it in. I apologize. I know I'm taking up a lot of time, but I think this example will be really beneficial for you. So we'll work here with the sine of 60 degrees times the cosine of 150 degrees times plus 3 times the sine of 150 degrees. This might look a little bit confusing when you look at it right away, but you know how to evaluate each of these 3 values. You know how to find the sine of 60 degrees. You know how to find the cosine of 150 degrees. You know how to find the sine of 150 degrees. And if you know how to evaluate each of these ratios, then you should be able to substitute in your values. So we'll try out the first one. Whoops. Actually, you know what? I'll encourage you. I'll say pause the video here and evaluate each of these 3 ratios. Once you've found those values, come on back. Good, so we've evaluated each of our 3 ratios here. We should be working with the sine of 60 degrees is root 3 over 2. The cosine of 150 degrees is negative root 3 over 2. And the sine of 150 degrees is 1 over 2. And we're going to take each of these 3 values and we'll substitute them in to the expression above. So we have the sine of 60 degrees. Well, the sine of 60 degrees, according to our work here, is equal to the square root of 3 over 2. Root 3 over 2. Good. Then we'll multiply that by the cosine of 150 degrees. The cosine of 150 degrees, I know that. I found that right here. That is negative root 3 over 2. So I have root 3 over 2 times negative root 3 over 2 plus 3 times the sine of 150 degrees, which is 1 over 2. So I'm working here. Okay, so I have, and I did run out of space a little bit. I did my best. Move that down there. Fantastic. Root 3 over 2 times negative root 3 over 2. I'm working with negative 3 over 4 plus 3 over 2. And so I should be working with, and I apologize again, I'm out of space here. That's okay. We'll move that over like this. This is equal to positive 3 over 4. Well done, folks. So at this point, you should be able to handle all of the practice problems from section 4.7.